Hey guys, this is Mr. Brengle, and today we are going to talk about developing the physics equation for different graphs. And this is just a shorter way of saying a mathematical expression that explains the data that we find in the graph. So the first thing I want to look at here is let's talk about, we've got a graph here and it's got a slope that looks something like this, okay? And so we should know that the equation for a line is y equals mx plus b. So the first thing that we need to do with this information is understand what all of that stuff actually means. So over here, this is your y-axis, right? So we're just going to put a y there. And then our slope is represented by this red line. So I'm going to put the m right there for slope. And then, of course, the horizontal axis is your x-axis. And then b would be your y-intercept. So that's where this red line crosses the y-axis. Okay, so in this case, I started at 0. So really, there is no y-intercept. However, if I were to redraw this graph the exact same way, except start from right here, well, then we could say, all right, well, this is the y-axis over here, this is the x-axis, here's our slope, and then b would be right here, the y-intercept. Something important to note is that the units of the y-intercept will always be the same as the units that you find on the y-axis. Okay? So once we understand this, we can actually go look at an actual graph and then pull the equation from the graph. So let's do that now. Let's go ahead and erase all of that, and I'm going to redraw. I'm just going to make a very simple position versus time graph here. Okay, so we'll do this right here. All right, so over here, position is in meters, and then time in seconds. And I'm going to draw from the origin a line like this, and then the equation that goes with this that you would put on your graph. I'm just going to make something up. I'm going to say that it's 5x plus 0. Okay, so this is just like the equation that you would put on your graphs in Google Sheets. And so this is the only information that we need to make the physics equation. So remember that our physics equation is going to be in the y equals mx plus b format, and we're just going to match everything up. Okay, so the y-axis is literally whatever is labeled on the y-axis. In this case, it's position. Now, position is designated with an x, but I actually want to write out the word position here. So position is equal to. Now, when it comes to slope, slope is the hardest part just because you have to figure out what the units are. Now, it's easy to find the numerical value for slope, so all I have to do is look up here at my equation that the graph gave me, and then I'm simply going to look for the numerical value that's right in front of x, because that is slope, right? If we were to actually make this equation, it would be y equals 5 would be m, x plus b, right? These match up right here. So then I would include the number 5 for my slope, and now I have to figure out what the units are. Well, I always like to do this. I always like to actually write out rise over run, and then I'm not actually going to put the variables on there. So I wouldn't put position and time, although we could, and actually let's go ahead and do that. So our x, or the rise in this graph, would be on our y-axis, and that's going to be position. I'm just going to say POS. And then the run would be time, which is on our x-axis. So now I want to know, what are the units for this? Well, if I look here, my units for position are meters, and then my units for time, seconds. So that right there, that's what I want. So now I know that my slope is equal to 5 meters per second. So I can plug that in there. Okay. Now I'm going to plug x in, and x is just whatever's labeled on your x-axis. Same idea as y. So now I'm going to write time right there. Just remember that whenever you write a word, you do not need units. Whenever you write a number, you do need units. So now we get to the y-intercept, and in this case, the y-intercept is 0, right? So if you follow my pointer here, this would be our y-intercept for this graph. So I would actually put in 0 here, and then I always want the same units as whatever's on the y-axis, which in this case is position, so my units would be in meters. Now, if your number is actually 0, you really don't need to include it, but I want to for the purpose of this graph here. Now, we're done with the physics equation. This is the physics equation right here. Now, what's important about this is that we can actually draw an equation from this graph that we use in physics all the time. So if I were to look at this and say, okay, well, position is x, right? There's two positions on here. There's this position, and then there's this one over here. So what's the difference? Well, your y-intercept over here is your starting position or your initial position. And then this position over here would really be your final position. So if we were to use this equation to figure out where will the position be at 10 seconds, then we could solve for that, and it would be somewhere along this line up here, and that's what we would be solving for with position. So I'm actually going to label this as the final position. This is equal to velocity, right? So this 5 meters per second is velocity times time plus our initial position, xi. Okay, so I could then further simplify this equation by subtracting xi off of the right side and putting it over here. And if we do that, and you have final position minus initial, well, that's the same thing as saying the change in position, right? So I could actually rewrite this as delta x is equal to velocity times time. Okay, and this is right here an equation that we use all the time. We can rearrange that for velocity. Velocity is equal to the change in position over time, or we could rearrange it for time. Okay, so this is the gist of physics equations and what we need to do with them. We want to be able to get these equations off the graphs so that you guys aren't just regurgitating equations off of an equation sheet. You actually know where they come from. So let's go ahead and erase this real quick, and let's do another example with position versus time. So let me label this here. Okay, but this time the line doesn't start at the origin, okay? So instead, when we put our equation on the graph, let's say that it was the same slope, so it came out to be 5x plus, and then we'll say 10, right? So basically what we're saying is that right here is position 10 on the graph, that notch right there. So let's do a physics equation using this data right here. So again, remember this is going to be y equals mx plus b. And I am going to find my y-axis, right, which is going to be position. That's equal to the slope, which, remember, the slope is right up here. It's that numerical value. And then the units, since it's the same graph, it's going to be same as what we did before. So this would be 5 meters per second. Then I'm looking for my x-axis, which is right here. It's just time. So I'm going to write that out. Now the difference here is that for the y-intercept, that is this number right here. So that tells me that my initial position was actually 10 meters. Okay. So again, when I go to make this into an equation that we use here in physics, I would say, okay, well, my final position is equal to the velocity, which in this case is 5 meters per second, times the time plus 10 meters. That is my initial position right there. So now I could take this and I could say, all right, well, if let's say this time only goes out to 10 seconds, okay, at this point. Well, what if I wanted to know what's the position going to be at 15 seconds? Well, all I would have to do is plug 15 into this equation for time. So then I could say, let me just erase this for a second, and so we could say that the final position is equal to 5 meters per second times 15 seconds plus 10 meters. And so if I were to do that math, that would give me the final position if my object starts at 10 meters to begin with, and then I run it for 15 seconds. And that is a tutorial on physics equations.